Hello class, today we'll be talking about 1.2, applications and modeling with linear equations. First we're going to be solving applied problems. We're going to have geometry problems, we're going to have motion problems, mixture problems, then we're going to model, we're going to do some modeling with linear equations. So, we have some steps for solving applied problems. The first step is read the problem carefully until you understand what is given and what is to be found. The second step is to assign a variable to represent the unknown value using diagrams or tables as needed. Write down what the variable represents. If necessary, express any unknown values in terms of the variable. Step 3, write down the equation using the variable expressions. All right, step 4 is to solve the equation. Step 5 is to state the answer to the problem and does it seem reasonable. Step 6 is the answer in words of the original problem. Check the answer. So let's go through an actual problem. Now, it says, for example, 1, it says, finding the dimensions of a square. It says, if the length of each side of the square is increased by 3 centimeters, the perimeter of the new square is more than twice the length of the original square. All right? So it says, find the dimensions of the original square. So the first thing we have to look at, all right? First thing we have to look at, let's say we have what? 2 squares. So we have the original square. Then we have some bigger square. And the original square says the size of what? I'm going to just use x. And then the other one, the big square is x plus 3. Because it said it's what? It's increased by 3 centimeters. So now, when we look at the perimeter of the big square, we know that it's a square, so all sides are the same. So we're going to just have what? We're going to have x plus 3. Times what? 4. And that equals what? 40. And then it says more than what? Twice the length. So it'll be plus 2x. All right? So because we have what? It says we have the perimeter of the new square is 40 more than twice the length of the original square. All right? So that's how we got it. So now we can go ahead and solve this out. It's going to be what? 4x plus 12 is equal to 40 plus 2x. Now we're going to get all our x's on one side and all our constants on the other one. So we're going to have 4x minus 2x is equal to 40 minus what? 12. So we're going to get 2x is equal to 28. And then I'm going to have x is equal to what? 14, because I'm going to divide 28 by what? 2. Now that we know x, we can actually find the size, right? So now if we're looking at the big square, it'll be what? 14 plus 3, which gives me 17. Right? So therefore, the perimeter of the big, if we look at the perimeter, is equal to 4 times 17, which gives me what? 68. All right? That's the perimeter of the big circle. I mean, the big triangle. I mean, the big square, sorry. So let's look at the perimeter of the what? Small one. So we found the perimeter of the big one. And then we know that dimensions of the other one is, you know, our x is just 14. All right? So we know that x is just equal to the 14. So if I did want to find the perimeter of the small one, I would just do what? 4 times 14. And then that would equal what? 56. Now, all I really wanted you to do is find the dimensions of the original square. All right? So we already know what the dimensions are. All right? So once we found the 14, we found what the dimensions are of the smaller square. Now, a square is easier because you don't have different side lengths. All right? All the sides are the same. So that's what makes this a little bit easier. Now, make sure if you have any questions about this, you hit me up on Microsoft Teams or you send me an email. So let's look at this, a motion problem. So, problem hint. In a motion problem, the components distance, rate, and time are denoted by the letters D, R, and T respectively. The rate is also called the speed or velocity here. The rate is understood as to be constant. So you have D is equal to RT, and its related forms are R is equal to D over T, and then we got T is equal to D over R. So basically they just solved that D is equal to RT out for R and for T, which you could do with any type of equation. So let's look at some things. We have another example. So we have Maria and Eduardo are traveling to a business conference. The trip takes 2 hours for Maria, and then it takes 2.5 hours for Eduardo since he lives 40 miles further away. Eduardo travels 5 miles per hour faster than Maria. Find the average. Their average rates. So if we were to look at Maria's, so when we think about Maria, then we think about Eduardo. I'm gonna make a little chart. All right, so her rate is X, and his rate is X plus 5, because he's going 5 miles per hour faster. Her time is 2 hours, his time is 2.5 hours. Now the distance, or the dr, would just be the r times the t, so it'd be what, 2x? And then this would be what? 2.5 times your x plus 5. Now, let's look at what we have. Now, all we got to do is do what? We have to do what? Set these both what? So let's look at what we got. Now, we have to look at, it says since he lives 40 miles away. So he lives 40 miles further. So we have, now I'll put this in a different color. We have 2.5 times x plus 5 for Eduardo's distance, and is equal to 2x plus what? 40. That's because what? Maria lives 40 more miles closer than what? Eduardo does. All right? So now we're going to go ahead and multiply this in. It's 2.5x plus 12.5 is equal to 2x plus 40. So I'm going to put all the x's on one side and all the constants on the other. So it'll be 2.5x minus 2x is equal to 40 minus 12.5. Therefore, I'm going to have 0.5x is equal to 27.5. Put that in the calculator. Then I'm going to divide by 1/2, which is the same as multiplying by 2. So and I'm going to get 55. Now, this just tells me what x is equal to. All right? So we found what? Our rate. Now, let's make sure this makes sense. So, in a different color, let's see if it makes sense. So, Maria, all right, drives how far? 2 times 55, and that equals what? 110 miles. Eduardo drives 2.5, all right, times what? 55 plus 5. All right, because we have to keep that in mind. So it's times 60, basically. And basically, that's 160 miles. 150, sorry. 150. Which we know that it was a 40-mile difference in between the two. So that works. This is just checking. Your x is actually what? You found your rate. So this is just checking to make sure your rate is correct. So just keep that in mind. So mixture problems. It says problem solving here. In a mixture problem, all right, involving solutions, the rate of percentage concentrate is multiplied by the quantity to get the amount of pure substance present. The concentration of the final mixture must be between the concentration of the two solutions making up the mixture. All right, so basically we're saying, let's say if I got 10% and 30%, when we mix the two, it should be in between the two. It shouldn't be 40%, it shouldn't be, less than 10%. It should be in between the two. That's all it's saying. Now, let's look at what we have here. All right, so it says a chemist. A chemist needs a 20% solution of alcohol. She has a 15% solution on hand and as well as a 30% solution. How many liters of 15% solution should she add to 3 mLs of 30% solution to obtain her 20%? Now, like we did last time, all right? So I have my strength. Then I have the liters of solution, Then I have what? Liters of pure solution or pure alcohol. All right. So we have what? We're going to have what? 15%. We're going to have 30%. And we're trying to reach our what? Goal of 20%. All right. So with this, our starting point is X. We know that we have 3 liters of 30%. Now we're adding these two together, so we have X plus 3. So to figure out how many liters we got 0.5 times X. Now, the 0.15 came from 15%. You change percent to decimal. Same here. You're going to have 0.30 times your 3 because it'll be the 30% times 3. And for here, we got 0.20 times your what? X plus 3. So now we know we're trying to add the first 2 to get the last one. So let's do that. So let's change colors. Change you to red. So basically, I'm going to have what? And I'll put it down here. I got 0.15x plus 0.30 times 3 is equal to 0.20 times x plus 3. Now, when we solve this out, we're going ahead and distribute things. So we're going to have 0.15x plus 0.9 is equal to 0.2x. Then we got plus 0.6. Now, you don't have to put that extra 0 on the end. Now, when we put everything on the same size, we got 0.15x minus 0.2x is equal to 0.6 minus 0.9. So this will just give me negative 0.05 x, and is equal to negative 0.3. Now I'm going to just go ahead and divide, and it's going to be x is equal to what? 6. Because you have 2 negatives and make a positive. Now, but are we finished? All right? Are we finished? So what's going to happen is, so we figured out how many liters of 15. So basically we figured out how many liters of 15% alcohol I got to add to 3 or 30% alcohol to obtain my 20%. So at the end of the day, we know we're going to end up with what? 9 liters of what? 20% alcohol. Because all we got to do is add the 6 to the 3, then we'll get what? 9. So you found your liters. So make sure if you have any questions about this problem, you contact me. Your second mixture problem. It says problem solving here. In mixed investments, we're talking about money now. Problems, multiply each principal by the interest rate in the time in years. You're going to see this may look familiar. And the amount of interest earned. So let's look. So an artist, all right, an artist has a painting for $410,000. He invests a portion of the money for 6 months at 2.65% and the rest for a year at 2.9%. The broker tells him 2 investments that earn a total of $8,761 How much should be invested at each rate to obtain the what? Interest. So, let's look at what we got. So, we know we started off with what? So, you're trying to figure out how much the first thing we invested. So, the first investment, we know we started off with X. So, we don't know how much. We got to figure that out. The second investment was $410,000 minus the first investment. We know that the rate of the first one was how much? 2.65. Now, me personally, I like to go ahead and write this in its decimal form. So I'm going to go ahead and write it in its decimal form. So it's going to be what? 0.0265. And we know the second one was 0.0291. Now, interest earned would just be what? All that multiplied together. So it'll be X. And let me get the time in here. We forgot to put the time. We're going to put the time in here. Give me 1 second. So let's go ahead and put the time in here. So for that first investment, it was how much time? 0.5. And then the other one was 1. And then we need to do the interest earned. Now, honestly, when you do this problem, you don't really have to make this chart. It's just to make the chart just to get your, this, for you can see what's actually going on. So interest earned is equal to X times your 0.265 times your 0.5. And then this one would just be your 410,000 times minus your first investment times your 0.0291. Now, and then you can put the 1 back here, but 1 times anything is just itself. So now what we're going to do with all of this is we're going to put it in form of an equation. Because we know when we add these two up, we should get the what? This total right here. We get it? So let's look at it. And I'm going to change colors. So what I'm going to do is go ahead and multiply the different numbers. So because we got some multiplication here that we need to go ahead and do. So we know we got 0.0. We got 0. This should be 0 here. Sorry. 0.0265 times 0.5, right? So let's go ahead and multiply that. So that's going to be 0.01325x plus, then we're going to have what? We got to distribute this into here, all right? So this is going to be 11,931. Then we're going to have minus 0.02291x. And we know it's going to be equal to our what? And I'm going to erase this because we should have it by now. It's going to be equal to our 8,761. So remember, I already multiplied these two, and that's what gave me this, right? Then I distribute it in, And that's how I got these right here. All right. So when we keep going, we're going to put all our x's. So we're going to do our like terms. And we'll get 11,931 minus our 0.01585. Now, you can just put this stuff in the calculator, of course. And it'll be 8,761. Now, I'm going to have negative 0.01585. X is equal to, then it's going to be 8,761 minus the 11,391. Now, we're going to have two things, so then we're going to end up with negative 0.01585. X is equal to negative 3,170. Then we're going to divide, we'll get X is equal to 200,000. We'll get X is equal to 200,000. So just make sure you check it. So you got 3,170. Then you divide it by 0.01585. And you get $200,000. So this is the amount you should invest. All right, for the first investment, to get what you need to get so you can obtain the amount that you're trying to get. So your first investment would be your 200,000. Then, so your second investment, so I say X2, which is your second investment, would be 210,000, right? Because all you do is subtract the 200,000 from the 210, right? I mean, from the 200,000 from your 4,001. I mean, your $410,000, and that's how you get this. So just keep that in mind. So let's look. So modeling with linear equations, a mathematical model is an equation or inequality that describes the relationship between two quantities. A linear model is a linear equation. So let's look at this problem. Let's look at this problem. So in this problem, it says a vented range hood removes contaminants such as carbon monoxide and nitrogen dioxide from the air at a rate of F liters of air per second. All right, then the percent P of contaminants that are also removed from surrounding air can be modeled by the linear equation P is equal to 1.06 F plus 7.18, where F is in between 10 and 75. What is the flow? What is the F, or the flow F must a range hood have to remove 50% of the contaminants from the airflow? So let's look at this problem. Now, we know, first starting out, we have to use what they give us. So they give us the model. Now, the thing is, they tell us that we need to figure out 50%. So we're going to use 50. All right, now we're going to solve. So we're going to have 50 minus the 7.18 is equal to 1.06 times the F. Then we'll get 42.82 is equal to 1.06 times F. Now we're going to divide. So I'm going to get F is just equal to, and I'm putting it in order, of course, 40.40. Now that's roughly, all right? So it's actually rounded. So basically, therefore, to remove 50% of the contaminants, the flow rate must be approximately 40.4 liters of air per second. So that's how much it would take for it actually to filter out 50% of the contaminants. So make sure if you have any questions about this type of problem. Now, the whole point of this is being able to read and interpret what the actual problem is saying. So if you have any issues with this, make sure you send me a message and I will respond back to you to help.